So today we're going to figure out what inverse functions are. So the formal mathematical definition of inverse functions are two functions, comma, f of x and g of x are inverse if and only if f of g of x equals x and g of f of x equals x. So two functions are inverses of each other if when I compose them in opposite directions, I get x always for my answer. Okay, so let's talk about things really quick. First thing we need to know is whether or not a function will have an inverse function. So how can I tell if a graph of something is a function? By looking at its graph. What test do I do? Vertical line test. So, does that graph pass the vertical line test?
Yes.
Okay. I will tell you that that graph is a function. This graph does not have an inverse. Well, here's the thing, is if it were to have an inverse, let's do an easier one. What's this a graph of?
X squared.
Okay, so we got y equals x squared. So what do you think the inverse of y equals x squared would be?
Negative.
How do you, so inverse functions undo each other. So the inverse of addition is subtraction. The inverse of multiplication is division. What's the inverse of squaring something? Okay, now if you're the one that takes the square roots, what are you going to get?
Two numbers.
Two numbers. So what are the two numbers you're going to get here when you take the square root? You get x equals plus or minus the square root of y, which is this graph. Is that a function? No. What fails the vertical line test? It fails the vertical line test. That is correct. There is no inverse of y equals x squared. So let's talk about that. You guys do think that the square root function is the inverse of the squaring function, don't you?
No, it's not.
My question for you, if I were to change this to y equals x squared for greater than 0, how would my black graph change? That part would go away.
Oh my God, it's that thing.
Okay? And then, if I were to take the square root of this, because x is always greater than 0, I would never have a negative number here, would I?
Then it would work. It's that thingy.
So, what I'm going to tell you right now is if graphs don't have inverses, we can restrict ourselves to sections of the graph so it will have an inverse. This graph right here, this function right here, with the restriction of x being greater than, or actually greater than or equal to 0, is not called the squaring function. This is called the restricted squaring function.
Are we going to have to find the point of those two concepts?
That would be. So I can restrict functions to come up with their inverses. The square root function is the inverse of the restricted squaring function. Does my square root function, just the upper part, which is that one right there, does it pass the vertical line test?
Yes.
So let's kind of go back and look at something really quick. My original graph looked like this. And when I tried to find an inverse of it, the thing I was trying to give an inverse looked like this. Can you think of any test that I could do with my original graph to tell me whether or not my inverse graph would pass the vertical line test?
Say that again?
Yeah.
One more time.
Looking at this graph, just by looking at this graph, can you tell me whether or not this one is going to pass the vertical line test or not?
No, it cannot.
There you go.
Yeah.
There is a horizontal line test.
Yeah.
If a graph passes the horizontal line test, it has an inverse. So in order for a function to have an inverse, it must pass the horizontal line test.
And what is it?
Jordan, a horizontal line test.
No,
Jordan.
Does this graph pass the horizontal line test?
As of now, no.
No, it does not have an inverse. Does this graph pass the horizontal line test?
Yes.
Does this graph pass the
No.
horizontal line test?
No.
This graph would not have an inverse.
Sorry.
That graph on the left, first one,
No.
No.
second one,
No.
No.
third one,
No.
fourth one,
No.
Yeah.
fifth one.
No.
Yes.
That one passes, it has an inverse.
Yeah.
That one,
No.
that one,
Yes.
Yes.
that one,
Yes.
No.
Yes.
Yes.
No.
that one,
Yes.
that one,
No.
No.
that one.
Yes.
No.
Yes, it passes the horizontal line test.
Oh.
That one,
Yes.
Yes.
and that one.
Yep.
Yeah.
Yep.
Okay, every one that you said no to, we can apply restrictions to them to come up with inverse functions over a restricted interval.
So how would you do that for the fourth one?
You are going to get the fourth one probably in chapter 4.
Well, how would we
I'm going to talk about that when we get to chapter 4. I'm only going to use half of it. I'm going to restrict myself to x is greater than 0.
Okay. What about number 3?
Number 3 you're going to get to when we get through trig, second semester. Okay? So 2 things I want you to know. In order for things to be inverses, when I compose them in each direction, I need to get x out. Okay? And that they need to pass the horizontal line test. Any questions on that general notes right there? Okay? So the first type of problem you need to do is you need to verify whether 2 functions are inverses of each other. 2 functions are inverses of each other. If you compose them in each direction, you get x. Okay, so please turn your books to page let's see which one's I'm going to do. I want you guys to turn your books to page 195.
Dinner.
So, problem 16. The directions say, verify that f and g are inverse functions. So, in order to verify things are inverse functions, you are going to compose them in both directions and see what you get. So, f of x is equal to 2x plus 3. G of x is equal to 1/2 x minus 3 halves.
Wait, which one is? Oh, I see it.
I'm doing number 16.
I see it.
Okay? So what I need to do is I need to write f of g of x and g of f of x. So f of g of x. It says to write down the outside function except where there's an x, put parentheses. So I'm going to write 2, open parentheses, close parentheses, plus 3. Inside the parentheses, write the inside function. Inside the parentheses, I'm going to write 1/2 x minus 3 halves. Now I'm going to simplify. Distribute. 2 times 1/2 is 1, so I have x. 2 times negative 3 halves is negative 3, plus 3. Negative 3 plus 3 is 0. X minus 0 is x. Just because you get the x the first way, you still have to check the second way. Because yesterday we said compositions are not necessarily commutative.
Oh, it's like when we were doing the triangles.
Correct.
Go through all of them, okay.
So I'm going to do 1/2 x. So I'm going to put parentheses minus 3 halves. I'm going to put a 2x plus 3. I'm going to distribute. 2 over 2 is 1, so I have x. 3 over 2 is 3 halves. Minus 3 halves. 3 halves minus 3 halves is 0. X plus 0 is x. Any questions on how to verify whether functions are inverses of each other? So what would be one of your questions you'd want to ask about inverse functions?
If there's only one, how do you find the inverse of it?
How do I find the inverse of a function? So let's think about that. What I'm going to do is I'm going to come up with a basic thing. If you have only one x in your equation for a function, for example, if I tell you f of x is equal to x minus 3 squared plus 5. Okay? If we only have one x in a function, we can kind of talk ourselves through it. Okay? So if I start with a number x here, what is the first thing that I do to the number x? If let's say I put a 4 in for x. What would be the first thing you would do to it in this equation?
Subtract 3.
You would subtract 3. And that would give you x minus 3. Do you agree with that?
Yeah.
And then what are you going to do to the x minus 3?
You're going to square it.
You're going to square it. And that would leave you with x minus 3 quantity squared. Then what are you going to do to it?
5 to it.
Then you're going to add 5. Okay, so that's the order that I would do something to evaluate. Well, what an inverse function does is it undoes everything I did in my original problem. So what we're going to do now is we are going to start on the right-hand side, and we're going to work backwards. If I start here with an x, and I work backwards, what is the opposite of adding 5?
Subtracting 5.
What's the opposite of raising something to the second power?
Square rooting it.
Take the square root of it. What's the opposite of subtracting 3?
Adding 3.
I'm going to put the plus 3 over here on the right so it doesn't look like it may be underneath the radical. That is the inverse function to that. Again, I'm going to have to put a restriction on my original function because that's a parabola and that fails horizontal line test. So if I say that only the right-hand branch, that would be the inverse of the right-hand branch.
Isn't it supposed to be x minus 5?
Yes. Thank you. I saw the 3 here.
Yeah.
How can I verify that they're inverses of each other?
Do the F of
Do the f thing, okay?
That thing.
So I'm going to call this g of x. So here's the thing. You know how to check your answers. So if I ask you to find an inverse, how can you tell if you got the right inverse? Check it.
Book.
So we're going to write f of x. Except where x goes, I'm going to put parentheses. So I'm going to write open parentheses, minus 3, close parentheses, squared, plus 5. Inside the parentheses, I'm going to write my inside function. 3 plus root x minus 5.
Oh, so you have to do literally everything backwards.
Okay, now what I'm going to do is I'm going to evaluate what's inside the parentheses as much as I can. Please pay attention across. What's 3 minus 3?
0.
And I'm going to leave this root 5 in here. What's the square root of x minus 5 squared?
X minus 5.
X minus 5.
And then that would be X.
And those cancel? Did going that direction work?
Mm-hmm.
So again, I would have to, in order to verify it's an inverse, do it the other direction also. Okay, and you should see that that's going to work because you're going to end up with the x minus 3 squared plus 5 right here. Okay, and the plus 5 and the minus 5 are going to cancel. You're going to have the square root of something squared. That's going to end up with x minus 3. The minus 3 and plus 3 will cancel, leaving you with the x. That is method 1 for finding the inverse of a function. I call it using an arrow diagram. Okay? I call it using an arrow diagram. That only works if you have a single x in your function. The next method will always work. There will be some caveats when we get to exponential functions and trig functions. But if it is algebraically possible to find an inverse function, the next method will always work. This is our 4-step method for finding an inverse. I'm going to start with the same function I started out with before. F of x equals x minus 3 squared plus 5. Step 1. Change f of x to y. So where it says f of x, I'm going to replace it with a y. So I get y equals x minus 3 squared plus 5. Step 2. Swap x and y. So everywhere there's an x, I'm going to replace it with a y. Everywhere there's a y, I'm going to replace it with an x. X equals y minus 3 squared plus 5. Step 3, which may involve more than one step. Solve for y. So if I want to get y by itself, first thing I'm going to do is subtract 5. So I get x minus 5 equals y minus 3 squared. Then I'm going to take the positive square root only, because I know my original parabola, I'm going to have to get rid of this left-hand arm in order for it to have an inverse. So I'm only going to solve for the positive one. If they want you to solve for the negative one, they're going to tell you that, hey, I want the left-hand one. So when I take the square root here, I'm just going to get the positive square root.
So you always go for positive unless
Yep,
they tell you negative?
unless they tell you otherwise.
So, before when you told us to solve positive and negative stuff.
Correct. If you are solving with a number issue, okay, right now I'm trying to find an inverse. I am not solving an equation to solve the equation.
Okay.
Okay?
I get you.
And you've got to remember, this does not have an inverse.
I know that.
This does.
Yeah.
Okay?
You just gotta limit it so it can.
So, and my last step is to add 3 to both sides. So that was step 3, which may involve more than one step. Step 4, change y to f inverse of x. This looks like raising something to the negative 1 power. It isn't. Anytime I have a function name where it looks like it's raised to the negative 1 power, we read that as inverse. So f to the negative 1 means f inverse. So we're going to change our y to f inverse of x and write our final answer as the f inverse of x is equal to 3 plus the square root of x minus 5. On a test or on a quiz, you may perform steps 1 and 2 at the same time. You can change f of x to y and swap the x's and y's at the same time. Everything else you need to do. Okay? If you are using the arrow method for showing me that how to find the inverse, this is what the kind of work you need to do. Show me the arrow method. When you are finding the inverse of a function, you need to show me work. You're either going to show me this, or you're going to show me this.
Yeah, we do that.
Okay? This way shows that you know what you're actually doing mathematically. Okay? So this is the way that your brain should be thinking about what's happening when you're doing an inverse of a function. I do it algebraically because that way I only have to know one method.
Mr. How did you, or Mr. Chip,
Yes?
I was gonna say, you wrote it down just so I can just keep going over. You can keep going, I'll just.
We're going to do a practice one with the 4-step chimpanzee method.
Did you get that, Rob?
Yeah.
Are you done with this part?
No, but I have it, I know what it is.
Well, this was the finding the thing.
You did it backwards just to check it and find the inverse.
So I want to find the inverse of that function. Can somebody tell me what the graph of that function is going to look like?
It's going to be it's not what you call it, or the other thing. It's not quadrilateral. Not quadrilateral, oh my god, quadratic or function. No, it's
Linear.
function.
It's linear?
No, it's not linear. It's
Oh, there's an X. So
it's the other one.
It's rational.
Not quadratic.
We'll see.
it's that? That thingy?
Oh,
What-
it's
what-
it's that one.
You think it's one of those?
Yeah.
We'll put some numbers in and see.
Because I
You remember doing
did
that
them.
work? Okay.
I remember
So
doing them.
step one is to change f of x to y and swap x's and y's. This method, I cannot use the arrow diagram with this one. I've got more than one x. So I'm going to write x is equal to y over y plus 2. I changed f of x to y, and I swapped x and y. My next step is to solve for y. I have a proportion. So what I need to do is I need to get everything in the numerators of the proportion. So I'm going to multiply both sides by y plus 2. Any questions on that step? I multiplied both sides times y plus 2. In order to solve for y, I need to get all the y's to one side of the equation. So I'm going to subtract. No.
Or subtract.
I'm going to subtract xy from both sides. I can't do anything with the thing that's got two y's in it, but it looks like I can factor a y out of both parts of the right-hand side. Do you see that? And my final step to solve for y is to divide both sides by 1 minus x. Final step would be to write this as f inverse of x. Any questions on the algebra I did there?
Wait, how do you get the parentheses 1 minus x?
He took
I
out
factored
the-
a y out of both terms on the right-hand side.
Okay.
Anybody have any questions on how I came up with f inverse of x like that? Notice I have a function that has a linear over a linear. I have another function which is a linear over a linear. Looks like I got some sort of function that's the inverse of itself. Kind of. Same type of function as the inverse of itself. You were right. That is one of our hyperbolas.
Hyperbola.
Okay? So,
Hyperbola.
what I'm going to do is we're going to just make a quick discussion before I assign the homework. And we're just going to do some quick things with graphs of some functions and their inverses. Okay? And I'm going to see if you guys can understand something with these graphs.
Sounded like wood.
So the first one I'm going to do is the restricted squaring function and
This thing?
the square root function. The restricted squaring function is the right-hand side of a parabola. The square root function is that. And that would be at 1. Okay?
Whoa. Wait.
The next one I want to do for you is two functions that are inverses of each other. Are the x cubed function and the cube root of x function. Does this have an inverse? Yes?
Yeah. Oh, that's so weird.
Those two are inverses of each other.
Holy guacamole.
What relationship do you see between those two sets of graphs? What do they kind of look like?
They look like spaghetti noodles.
They're intertwining.
They're intertwining. Well, let me draw something else that are inverses of each other.
Dude, they look like X chromosomes when they're overlapping each other and swapping DNA.
So a helix?
Get your science head out of here.
No,
That's what DNA is a double helix.
not when it's in X chromosome form. When they overlap each other, they're like.
Is that a function?
Yeah.
That
Does
is-
it have an inverse?
I would have to say, unfortunately.
I would imagine. Oh, that's so cool.
Wait, it's not a function though. It doesn't pass the horizontal line test. You said it right there. It goes straight down along that line for a second. Like not for a second.
Well, kind
Did you
of.
not
That would be its inverse.
Wow.
What relationship do you see between the blue and the purple graphs?
The little dippy thingies go inside the other little dippy
They're reflections
thingies.
of each other.
Across what?
The x y the y equals
Origin?
x the y equals x line.
Bingo.
Oh my god, I said something smart.
That's why I said like the origin. Because I didn't know how to say it.
David, just do this.
Does anybody remember what we called y equals x function, what its name was?
Nope.
Starts with the letter I.
Identity function.
It's the identity function.
Haha. I remember my turn to be smart.
The reason why it's called the identity function is because every function and its inverse are reflections of each other across that function.
Whoa.
What is the multiplicative identity number? What number do I multiply to get back to my original number? 1.
Yeah. I was like,
Okay.
just one.
Oh yeah.
So,
Cross. Stop.
what was my second step of my chimpanzee method?
Swap X and Y.
Okay.
I thought you said swalk.
Swap X.
Swap x and y. So I'm going to show you how to find the inverse of a function from its graph. We're going to use the second step of the chimpanzee method. First thing, my function has to have an inverse.
My first thought was that of a who. Yeah, Cindy the Who.
Who?
Mr. Grinch.
Please cut that right now.
So that's my function. I want to graph its inverse.
Uh,
So all I'm going to do is I'm going to find the coordinates of the key points, and I'm going to swap their x's and y's.
oh, so they go
Keep the
across
things on the line that are the
Isn't
same and
that
then-
just mirroring it across the y-axis?
Yeah.
No. So what's the coordinates here?
Negative
-2,
2.
-3.
Yeah.
Negative
So
4.
it'd be.
This one is -1, -1.
Would it be 4?
This one is
Would it be
0, 0.
Wouldn't it
This
be,
one is 1, 1.
What do you mean negative 4? That's negative 3.
Uno, dos. Okay, thank you. I guess it's 3. And this one right here is at 3. This one's at 2, 2. And this one's at 3, 1, 2, 3, 4. Don't trust myself. Now all I'm going to do is I'm going to start at the bottom group, and I'm just going to swap the x's and y's, and I'm going to plot them in purple, I guess.
-3, -2.
So -3, -2. -3, -2.
Yeah.
-1, -1. 0, 0. 1, 1. 2, 2. 4, 3. So now what I got to do is I got to kind of mimic the shapes. See how this one is curving down this way? So this one will be curving up that way. This one's curving like that, so I'll bet you this one is going to be curving like that. This one's straight, so it's going to be straight. And then this one's going to end up curving like that. If I were to draw the dotted line of y equals x, they would be reflections.
Wait, so
of
you
each
don't
other.
make it go this way instead?
No,
It
I
looks
swap
like
my x's and y's.
It looks like cross.
So the line of reflection is the line that goes right through these points.
Which is
It's a mirror image of each other across that line. So the key thing I want you to remember is finding an inverse function. If I give you a table or if I give you a graph, you can find values of the inverse of the function just by performing the second step of the 4-step method. Swap x's and y's. That will come into key plays when we start trying to find inverses of the graphs on the right and the graphs on the left up on the board.
This is gonna be.
Any questions on inverse functions, verifying their inverses, and finding inverses? No?